Good morning, everyone. Welcome to week 2, lecture 3, Zero Choice, Budget Constraint, and Utility Maximization. In today's lecture, we are going to study consumer preferences. We are also going to analyze the effect of a change in price on the budget line. We are also going to analyze the effect of a change in income. What happens to the budget line when income changes? At the same time, we are going to look at what happens to the budget line when the price of the good changes. Now, if you look at the effect of changes in prices on the budget line, we have two separate effects here. The first effect is the substitution effect, and then the next effect is the income effect. So in this lecture, we are going to look at both effects. We are going to look at both the substitution effects and the income effects resulting from a change in price of the good. So we are also going to obtain the optimal values from a utility maximization problem. And I said earlier that the optimal values from a utility maximization problem referred to as the Marshallian demand curve, Marshallian demand function. So in order to obtain or derive the Marshallian or ordinary demand function, which is also called the uncompensated demand function, we need to obtain the optimal values from a utility maximization problem. So let's go ahead and get started. Now, what is the budget constraint? What is the budget constraint? Now, we're talking about consumer preferences, and then we're also talking about the opportunities here, right? So the budget line is used to illustrate what? The consumer's opportunity, not consumer's preferences. We use the indifference curve to illustrate consumer preferences. So there are two cases here. You have the indifference curves, which is used to illustrate consumer preferences, whilst the budget line is used to illustrate consumers' opportunities. So, these are two diagrams here. There are two diagrams here. You have the budget line, which is a straight line, and then you also have the indifference curve, which also slopes downward from left to right. Whereas the indifference curves illustrate consumer preferences, the budget line is used to illustrate the consumer's opportunities. So let's don't forget about that. Let's try to remember that. Budget line is used to illustrate the consumer's opportunities, whereas difference curves normally used to illustrate consumers' preferences. Okay, so we dealt with consumer preferences earlier, and now we are going to look at the budget line, then try to see where the indifference curve is tangential to the budget line. At a particular point, consumer is in equilibrium. That is to say, the slope of the budget line is equals to the slope of the indifference curve, which is MUX or MEY. In other words, the marginal utility spent per dollar on one good must be equals to the marginal utility per dollar spent on the other good. If we are dealing with N goods, then the marginal utility per dollar spent must be the same across all commodities for the consumer to be in equilibrium. And that equilibrium point is referred to as the optimal point, the point where the consumer maximizes its utility, subject to its budget constraint. So the budget line is just a set of bundles, or the budget constraint is just a set of bundles of goods that a consumer can buy with a limited amount of income, right? So no consumer will go beyond its budget line. So you have your own set. So all points below the budget line and on the budget line are attainable. They are all feasible. But all points outside the budget line or away from the budget line or to the right of the budget line, all those points are not attainable. In other words, the consumer cannot afford to be away from the given budget line. The consumer cannot afford to be out of the budget line, so he has to be within that particular set. So if we look at two sets of goods here, let's say you have food and clothing. Now you want to find the budget constraints for those two goods. So how much money do you spend on food, and then how much money do you spend on clothing? Now remember, we say the consumer is limited to the amount of money that he has. Is limited to his income. That is constrained by his income. The consumer is constrained by his income. If, let's say, you earn maybe $100 per week, so if you have that $100 and you are going to spend it maybe on food and clothing and nothing else, so that $100, you have to allocate your resources so that you'll be able to spend that $100. So you're going to allocate your resources in such a way that it fits the 100. It is just exactly equals to $100. The expenditure on the two groups must be equals to $1, either less than or equals to $100. Now, if the expenditure on the two goods is less than $100, then the remaining amount will be saved, right? So in this particular case, let's say the income is M. If the income of the consumer is M, and then you have two groups, food and clothing. If the price of food is PF dollar and then the price of clothing is PC dollars, then the expenditure on food is just the price of food multiplied by the quantity of food. Now we are going to represent the quantity of food here as F. F is the quantity of food consumed by the consumer. Then C represents the quantity of clothes or quantity of clothing consumed by this hypothetical consumer. Now, if we take the sum of the expenditure on food and the expenditure on clothing, that total amount will be equals to the consumer's income, which is $M. So as you can see here, we have the budget line given as this: M equals FPF, which is the expenditure on food, plus CPC, which is the expenditure on clothing. So the individual consumer here spends all his fixed income on these two goods, assuming that these are the only goods that he is going to buy or that he is going to spend his money on. So this is the budget line, which is a straight line. So in this regard, if you want to find the intercepts on the food axis, all you need to do here is to divide throughout by PF. If you divide the budget line throughout by PF, you're going to have the intercept on the food axis. Similarly, if you divide throughout by PC, you're going to get the intercept on the clothing axis. So if we say we have the clothing axis on the horizontal line, and then let's say the vertical line represents maybe food, right? So we have food here. This is our food. For those of us who like to eat, so we have that one. And then we have clothing here, which is on the horizontal axis, right? I want you to pay attention here. This is really interesting, right? So that is the horizontal axis. So you have the vertical axis where we have food, and then the horizontal axis we have clothing. So looking at this budget line here, M equals to FPF plus CPC. So we want to find the intercept. What is on the intercept here on the food axis? So we have M here. This is our income, and that is equals to what? FPF plus what? CPC, right? Let's try to have this one. Now, I said we want to find the intercept on the food axis. How do you do that? I told you earlier that if you want to find the intercept on the food axis, you divide by what? You divide this budget line by what? PF, throughout by PF, right? And then you solve. If let's say you have two goods, X and Y, and then the consumer's income is M, right? If we have those two goods, then the budget line will look like, the budget line will be what? M equals XPX plus YPY. Have you seen? XPX is the expenditure on good X, And then YPY is the expenditure on good Y. So if we add those two, we're going to get the income, okay, of the consumer. So now here we have FPF plus CPC, and that gives us the consumer's income. But I said here, if we want to find, let's say, the intercept term on the food axis, we divide by what? PF, right? So if we divide M by PF here, we're going to have this. And then if we divide FPF by PF, of course, we know that this PF and this PF cancel, right? And then plus, we divide this by what? PF again. So we have CPC over PF, right? So as simple as that, what we need to do now is to transpose this other term. Now leaving F on the maybe the right hand side. So we're going to have F equals to M over PF, right? And then minus, remember this CPC over PF, if we transpose that to the other side of the equation, we're going to have minus what? PC over PF, and then what? C, right? So clearly, we notice that this M over PF is the intercept term for any linear equation, right? So what do? We just plot this one here on the vertical axis, and then we write what? M over PF. Have you seen? That's how we got this one, M over PF. Now we have that intercept. But we want another intercept on the horizontal axis. How do we go about doing that? That one is also simple. Previously, we divide both sides by the price of food, right? To get the intercept on the food axis. Now, if we want to find the intercept on the clothing axis, we have to divide throughout by the budget line by what? By PC. That is the price of clothing, okay? And then we solve. Now, let's go ahead and do that. Now, we have M equals to what? FPF and then plus what? CPC, right? Now, what do we do here? We say we have to divide the entire budget line by PC because we want to find the intercept on the clothing axis, which is the the horizontal axis. So divide by PC, right? And then we do the same thing to CPC by PC. Remember PC and then PC all cancel, right? So we are left with T. So all we need to do now is to transpose the FPF to the other side of the equation. And if we do that, we're going to have C equals M over PC, right? M over PC minus PF minus what? PF, right? Over PC and then F, right? So you see M over PC here, this M over PC, this whole M over PC represents what? The intercept on the clothing axis. So you write here M over PC. That's how we got that one. Then we join these two lines like this. And now we have the budget line, right? So what is now the slope? The slope is what? Is PC over PF or PF over PC. That's the slope, right? In other words, it is the ratio of what? The prices of the two goods. So the ratio of the price of the two goods is the slope of the budget line. Okay? Which is what? Minus maybe PF. In this case, we say minus PC over PF, right? So that is the slope of the budget line, right? And we have to say minus here because that line is downward sloping. It has a negative slope. That's why we have the minus sign there. Okay. Okay, let's continue. Now, before we move further, you know what the budget constraint is now, right? What the budget constraint is. It is just what? A set of bundles of goods that a consumer can buy with a limited income, with his limited income or a limited income, right? Now, if you look at this budget line here, all these points here, all the points in this within this region, if we take any point here, all these ones are what? They are feasible, they are attainable. But if we take any point outside this budget line, because they are not attainable, in other words, they are not feasible. Consumer cannot afford to be on that end of the budget line. Okay, so let's move ahead. Now, so the mathematical derivation we have done. So you see how we obtain the budget line. So what we do here, we divide either both sides by PF or we divide by PC to get the budget line, right? So now let's look at two cases here, XPX plus YPY equals to M. So here I want to find the budget line here. All we need to do is to divide both sides by PY and then the other one by PX to get the budget line. Now if we divide both sides by PY, we're going to have M over PY minus PX over PY X, right? Divide both sides by PX is M over PX, X equals M over PX minus PY over PX, Y. That is the budget line. Now, if we look at this budget line here, you see this is the opportunity set of the consumer. And all these points in here, they are all attainable. All these points are attainable. All these points here, any point within here, they are attainable, right? But if you leave this line, you go to point H is not attainable. This represents the unaffordable set of the consumer. So the consumer cannot be there because his income is only limited to what is on what? The budget line. Okay? So the slope of the budget line is negative. That's a negative slope. Because if you look at this, you see that it has a negative slope downwards from left to right. Now we're looking at the effect of a change in price. What happens to the budget line? Now remember we did this one um, under prices and the gains from trade, right? So this is just to recap what we did here. You see when relative prices increases. Well, here we are not talking about relative prices. Here we're talking about what? Talking about the talking about the prices changing the change in price, the single price, what happens to the budget line. So if the price changes, what will happen to the budget line? The budget line will never shift when the price changes. It only rotates either inwards or outwards. For a falling price, the budget line is going to rotate outwards. That is for a falling price. And then for an increase in price, the budget line is going to rotate inwards. So what do I mean here? If you don't understand what I meant here, we have Y here, and then we have X here on the horizontal axis, right? So originally, let's say we have our budget line here, right? We have M over PY here. And then we have our X1 and then maybe our X2, something like that. So if the price of the good increases, what will happen to this budget line? Is it going to rotate outward or inward? If the price increases, it is going to rotate inwards like this. It's going inwards. Have you seen? It is going to rotate inwards. So this is a new price, right? Okay. But what happens if the price falls? If the price were to fall, then this budget line is going to rotate outward. That is for a falling price. Now remember, this is for an increasing price, right? It is rotating inwards. And then for a falling price, it's going to rotate outwards. Okay? So this budget line is going to pivot outwards. In other words, it rotates outwards for a falling price, and then it's going to pivot inwards or rotate inwards for an increasing price. Please don't mix this up. When the price increases, the budget line rotates inwards. When the price falls, the budget line rotates outwards. Right? Is that clear? All right, let's move on. Now, look at the changes in price here. What happened here? You see, when the price falls, the consumer is worse off because of the loss, right? So we have this green dotted line for the falling, for the increase in price. When the price increases, the consumer is worse off, right? But when the price falls, the consumer is going to be better off because his real income has increased. So he's going to be better off because of the falling price. And so what happens here is the budget line is going to rotate outwards. Okay? Now this is for good Y. Changes in the price of good Y. Now let's look at the changes in the price of good X. What happens to the budget line? Now if you look at the budget line here, again, you see that when the price falls, the budget line is going to rotate outwards, which is the green dotted line. And then when the price increases, the budget line is going to rotate inwards, which is the purple dotted line. So as you can see in the arrows here, so you see that when the price increases, the consumer is worse off because what? His real income has fallen because of the increase in price. So he's worse off. He's not better off. Okay? When the price falls, then the consumer is going to be better off. Because with that falling price, he can buy many goods with that. Okay? So he's better off with the falling price. Now, let's look at the income. What happens to the budget line when income changes? Remember, I told you earlier that when the price changes, the budget line just rotates outwards and inwards, right? But here, it is not going to happen. It is not going to happen. So, now there is a difference between this and the case where price changes. When price changes, the budget line is going to rotate either inwards or outwards. And this also going to change the slope of the budget line, right? So when the price changes, the slope of the budget line will change. So if the price falls, the slope will change and then becomes steeper, right? Now let's look at what happens when the income changes. When the income of the consumer changes, the budget line shifts either to the right or to the left. So there is no rotation here. The budget line is not going to pivot because of changes in income. It is going to shift, a complete shift in the budget line, either to the left for falling income or to the right for an increase in income. Okay? So an increase in income in effect uh, will lead to an outward shift in the budget line, and a fall in income will lead to what? An inward shift in the budget line, right? For a decrease in income. Now, what will happen to the budget line when income and prices increases simultaneously? Oh, that's a red flag there. So, does anybody know what will happen when prices and income increases simultaneously to the budget line? Is it going to shift to the right or to the left? Is it going to pivot? So here, if both prices and income changes simultaneously, then the old and the new budget line are going to cross each other. They will cross each other. Okay? Instead of having either an increase, shift, or a complete rotation of the curve, have a point where those two curves will be equal. Okay? They intersect at a particular point. Now, just for an illustration here, now you see what will happen when the income increases. You see the budget line shifts to the right when the income increases, and then when income falls, the budget line shifts towards the left, as you can see in the two diagrams here. So if both the price of a good and income increase simultaneously, the old budget line and the new budget line will intersect each other. They will intersect each other. Now, please know that. I want you to know this one. If both the price of a good and income increases simultaneously, the old budget line and the new budget line will intersect each other. Okay? So if you have like those short answer questions, or maybe those true and false questions, please be mindful that something like this might come, or maybe you have objective multiple choice, this again might come. So make sure you know this one when the income and the price changes or increases simultaneously. Okay, what happens to the budget? Let's move now to consumer choice and utility maximization. Now, remember, I told you consumer choice, utility maximization is what we use to obtain the ordinary demand function or the Marshallian demand functions, right? So here, we say the consumer's optimal choice is the choice what of a bundle of goods that maximizes his or her utility given his or her limited income, right? So given the consumer's limited income, maximizes utility subject to this constraint. Now, to determine the consumer's optimal bundle of goods, we need to bring consumer preferences and opportunity together. So we're going to bring the opportunity of the consumer, the budget constraints, and the indifference curves the consumer's opportunity sets, and then the consumer preferences. We bring them together in order to get the consumer's optimal bundle, right? So with this limited income here, this occurs at the point where the indifference curve is tangential to the budget line. That is at the point where the marginal rate of substitution of X for Y is equals to the relative prices of the two goods, right? Now, if we look at the diagram here, we see that at that particular point, point E, the point where the indifference curve is tangential to the budget line. At that particular point, consumer maximizes its utility. Now remember, that is referred to as what? An interior optimum. Now this is not a corner solution. There is no corner solution here. So this is an interior optimum. So we're going to look at corner solutions when we deal with utility linear preferences that are linear, okay, or quasi-linear preferences. If we deal with quasi-linear preferences, then you're going to see those corner solutions popping up. So, but for this one, this is just an interior optimum of the consumer, MUX over MUY equals PX over PY, right? Remember, the slope of the indifference curve is what? MUX over MUY, and then the slope of the budget line is PX over PY. So, why is it that point A is not an optimal point? Why? It is not an optimal point because the slope of the budget line is not equal to the slope of the indifference curve at that particular point. Similarly, if we look at this other point down here, the slope of the budget line is also not equal to the slope of the indifference curve, right? So as a matter of fact, the only point where the consumer can be is point E, and that is referred to as its interior. Okay. So now we have a problem here. We are going to maximize utility subject to the consumer's budget constraint. Now, there are two approaches here to obtain these optimal choices. You know, there are two methods here we need to be aware about. The first one is a simple method where you just find the marginal utilities of the two goods, and then you just take the ratio of those two marginal utilities and equate that to the ratio of the relative prices, and then you solve. So that one is straightforward. But now, if you want to use the other method, which is the Lagrange multiplier, you're going to have a composite function in which the utility function, in other words, the objective function and the constraint are all put together. So we call that one a composite function. So when we have a composite function, then we are going to use the Lagrange multiplier, which is just the marginal utility of income. Okay? That Lagrange multiplier is referred to as the marginal utility. Now let's look at this interior optimum here. We said the marginal utility per dollar spent on each good must be the same. And the consumer is to be at equilibrium. So MUX over PX equals MUY over PY or MUN over PY, right? So in calculating the optimal amount of goods here, so we use the Lagrange multiplier, which is the most difficult method. And I know some of you don't want to use, don't want to have maybe something so difficult like this. Or we may use the simple method where we just find the marginal utilities of the two goods and then take the ratio of those two. They will divide by xpx, sorry, by px over py. They will solve, that's it. They will get the answer. Now let's use the Lagrange multiplier, this method here. So what we do here, we get this composite function, which is this one. This is referred to as a composite function. It's a composite function in the sense that it embodies both the utility or the objective function and the constraint of the consumer. Remember, the budget constraint is m equals to xpx minus ypy plus ypy, right? Xpx plus ypy. But now some of you will say, oh, why do we have a minus sign here, minus sign? Oh, some people are kind of frustrated. They see something like this, this equals xpx, right, plus ypy, right? So if we want the composite function, all we need to do is to take those terms on the right hand side to the left hand side. So we have m minus xpx and then minus ypy, okay? And then we slot this one into, remember this one should be equal to 0, right? If you bring all this term to the right, to the left. So just slot this m minus xpx minus ypy into this equation. And then we have plus lambda. Lambda there is the marginal utility of income. It is referred to as the Lagrange multiplier. So the lambda there, what? Is the rate at which that composite function changes as the income of the consumer changes. That is why we call it the marginal utility of income. Okay? So now, if we have this function, xy, remember, is the utility function, plus lambda to 400 is the income, minus 2x minus 2y, right? So remember, the price of x is 2, and then the price of x is 2. Oh, so please change this one to y. It is not x, so please change this to y. Please, thank you. So now what we do here is we have this as our Lagrangian function. So all we need to do is to find the first order condition, which is the first order derivative. So the Lagrange, the x is what? Is y minus 2 lambda. Remember, this is y, xy, derivative just y, and then you have 2x here, lambda becomes minus 2 lambda equals to 0, right? And then the Lagrange dy is x minus 4 lambda equals to 0. So you have the minus here and then minus 4 lambda. And then the Lagrange, the lambda is 400 minus, of course, we only treat this one, 400 minus 2x minus y, 4y equals to 0. So these are the equations. So what we're going to do is we are going to take these two equations first, and then we try to solve these two first, and then we'll plug in the answer to this third equation. That's how we do it, simple. So let's move on. Now let's take equations 1 and 2. If we take equations 1 and 2, we have y minus 2 lambda equals to 0, which implies y equals to 2 lambda, right? X minus 4 lambda equals to 0, which implies x equals to 4 lambda. So what we do now is we divide 4 by 5. If we divide equation 4 by 5, we have y over x equals to 2 lambda over 4 lambda, and that gives us what? If we solve, we have x equals to 2y, right? So from equation 3, we say this is the equation 3, the derivative of the Lagrangian function with respect to lambda, right? With respect to the Lagrange multiplier is equals to this. So all we need to do, we know what our y is. We just plug those ones into this. Now we know x equals to 2y, right? Instead of x, 2x here, we have 2 times 2y minus y equals to 0. So 2 times 2y is 4y, and then we have minus 4y is what? Minus 8y. So we have 800 minus 8y equals to 0, which implies 400 over 8 is equals to what? It's equals to 50. Okay. So to obtain x, we substitute for y equals to 50 into what? X equals to 2y. And that gives us what? X equals to 2 times 50, which is what? 100, right? So therefore, the optimal values of x and y consumed can be what? X is what? 100, and then y is what? 50. So those are the optimal values. Remember, these are referred to as the demand for the ordinary demand for the good. Okay? For each good. Now let's look at the easy approach. As I said earlier, all we need to do is to get the tangency condition, which is what? Mux over muy equals to px over py. Once you have that one, you know what is mux is the derivative of the utility function with respect to x, which is just equals to y. If you have u equals to xy, so the u dx, the u by the x is just equals to y, right? Likewise, the u by the y is also equals to x. Okay. So since px equals to 2 and then py equals to 4, if we plug in those ones, we're gonna have what? Y over x equals to 2 over 4, right? And then if we do that, y over x equals 2 over 4 implies 2x equals to 4y, or x equals to 2y. Then the budget constraint is given as what? M equals to xpx plus ypy. We just plug in for x there, and then instead of that, we have 2 times that, which is 4y plus 4y is 8y. So 400 equals to 8y, y equals to what? 50. Then we know that x equals to 2 is equals to 2y. So since y is 50, so 50 times 2 is 100. Okay, so you see clearly the result we have here is the same as the one we obtained when we use the Lagrangian method. Okay, so whichever method you want to use, I think it is fine. If you are the sophisticated type, then you can go in for the Lagrange method. If you are just easygoing guy, then you can take something that is simple, which is this one. Okay, so we don't need to be sophisticated. Try to do something that you think, or something that you know very, very well. Okay, specialization, man. Okay, something that you can do very well. That's what you do. That, you're gonna operate efficiently. Okay, now, this is just like a class exercise, or maybe if you are at home and I need you to solve this one. Suppose the consumer buys 2 goods x and y, and the utility function is expressed as this. Now, I want you to find the consumer's optimal, set up this problem, and then find the marginal utilities to use. Then determine the optimal consumption bundle. Try to get the optimal consumption bundle. Okay, so I'm going to stop here for now. I wish you all the best, and I've graded the midterm exams, so you can go ahead and look at your grades. Go to the course homepage, try to look at your grades. If you have not done that well, please make sure the next midterm exams you are able to do very well. Okay, I wish you all the best, and I hope we're gonna have fun together. Bye for now.